On November 27th, something unusual happened in artificial intelligence. Two Chinese research labs released models that, frankly, were not supposed to exist, at least not publicly, and not at this level of performance. One of them just outperformed the best human mathematicians on some of the hardest math competitions in the world. The other, with only 1 billion parameters, is outperforming multimodal giants several times its size. And here's the part that really shook the industry. Both models were released as open source. No API lock, no closed access, no corporate gatekeeping. Today, I want to explain what these models are, how they work, and why their release may mark a turning point in the AI race, especially for anyone working with AI, data, or automation. Let's start with the one that caused the biggest shockwave. DeepSeek has released Math V2, a model specialized in mathematical reasoning. And when I say specialized, I'm not talking about solving textbook equations. I'm talking about performance at the level of international math Olympiads. To understand how extreme this is, consider the Putnam competition, widely regarded as the hardest undergraduate mathematics exam in North America. In December 2024, nearly 4,000 students spent 6 hours solving 12 problems. The best human score that year was 90 out of 120. The median score was 2. Yes, half of all participants scored 2 points or less. DeepSeek Math V2 scored 118 out of 120. Not a typo. An AI model outperformed the best human competitor by 28 points, and it didn't stop there. On the International Mathematical Olympiad 2025 problems, the model solved 5 out of 6 questions, reaching gold medal level. But raw performance is not the most interesting part. What makes Math V2 fundamentally different is how it reasons. Most math-focused AI systems today are trained to optimize a single thing, getting the final answer correct. Reinforcement learning rewards the model when the output matches the expected result. That works for multiple choice exams. It works for benchmarks. But it fails at real mathematics. In serious math, the answer alone is meaningless. What matters is the proof, the logical structure, the rigor, the validity of every step. A model can reach the right answer by accident, with flawed reasoning that cancels itself out. Traditional training doesn't detect that. DeepSeek addressed this problem directly. Math V2 is built around what they call self-verifiable reasoning. The model is no longer judged only on the outcome. It must justify every step and evaluate itself. The system uses a 3-layer architecture. First, there is a verifier. Think of it as an Olympiad grader. It does not check whether the final answer is correct. It reads the entire proof and scores it based on rigor, logical coherence, and completeness. Full points for a clean derivation. Partial credit for correct but incomplete reasoning. 0 for logical errors or missing steps. Second, there is a meta-verifier. Its job is to verify the verifier, because even large models can hallucinate errors or penalize valid proofs incorrectly. This second layer dramatically improves reliability by monitoring the grading process itself. Finally, there is the generator, the AI model that produces the proofs. After each solution, the model must evaluate its own reasoning. And here's the key innovation. The model is rewarded for honesty, not just correctness. If it detects a mistake and admits it, it receives a positive reward. If it confidently presents a flawed proof, it is penalized. This flips a core weakness of current AI systems. Instead of manufacturing confidence, the model is incentivized to doubt itself, inspect its logic, and correct errors. The result is a massive reduction in hallucinations and a far more stable reasoning process. Even more interesting is how the system improves over time. Difficult or ambiguous proofs automatically become new training data. The verifier improves, the generator improves. the entire system co-evolves, without requiring thousands of human mathematicians to label data manually. And despite its size, 685 billion parameters, the model is publicly available on Hugging Face under the Apache 2.0 license. While OpenAI and Google keep Olympiad-level math models locked behind closed doors, DeepSeek released theirs to everyone. That alone changes the balance of power. But that wasn't the only surprise this week. Tencent released Hunyuan OCR, a model focused on optical character recognition. And at first glance, it shouldn't be impressive. Only 1 billion parameters, yet it consistently outperforms much larger multimodal models, including systems 4 to 5 times its size, and even some commercial APIs. To understand why this matters, you need to understand how OCR usually works. Traditional OCR systems are pipelines. One model detects text regions, another segments them. A third recognizes characters. A fourth reconstructs layout and structure. Each step introduces errors. Those errors accumulate. Tencent asked a simple question: why are we still doing it this way? Hunyuan OCR is end-to-end. You give it an image, and in a single pass, it handles text detection, document understanding, information extraction, translation, and visual question answering. No fragile tool chains, no cascading failures. The architecture is carefully optimized. The visual encoder is only 400 million parameters, but it accepts images in their original resolution and aspect ratio, instead of forcing everything into square inputs. This matters in real-world OCR: long receipts, wide tables, multi-column documents, distorted scans, poor lighting, screenshots, folded pages. After visual processing, a compression module reduces visual tokens without losing text-critical information. This keeps the language model lightweight and fast. The language model itself is only 500 million parameters. It uses a technique called X-drop, which treats understanding across 4 dimensions: text content, page height, page width, and time, for video frames. That's why it can handle multi-page documents, flowing layouts, tables, forms, and even moving subtitles. The results are difficult to ignore. On Tencent's internal benchmark of 900 OCR images across 9 categories, it reached a 71% overall score, beating established OCR systems and generalist VLMs. On OmniDoc Bench, one of the hardest public document benchmarks, it scored 94%. On OCR Bench, it achieved 860 points, becoming the best model under 3 billion parameters. It also ranked first in the IGDAR 2025 document translation competition for small models. Even under degraded conditions, folded documents, poor lighting, recaptured images, it maintained over 85% accuracy. Across 14 non-English languages, it reached 91% accuracy and set new records. All of this with 1 billion parameters, fully end-to-end and ready for large-scale deployment. When you look at these 2 releases side by side, something becomes clear. They represent 2 seemingly opposite philosophies. DeepSeek pushes massive specialization to the extreme, enormous models achieving unprecedented reasoning depth. Tencent proves that with intelligent architecture and focus, small models can outperform giants. The industry is now asking a critical question: will the future belong to ultra-specialized models or general systems that do everything reasonably well? The most likely answer is neither. The real shift will come from orchestration, systems that know when to call a specialist and when to rely on a generalist. And that changes everything, because the advantage no longer comes from model size alone, but from how intelligently systems are composed. One thing is certain: the pace is accelerating. And for those who understand these shifts early, the next few months will be decisive. This transmission ends here. The next one is already forming. Stay aware and subscribe to Remain in the Signal.